Hello my friend, it's time to make the same program we did in the last lecture, but this time using the recursion version. So we want to invoke a function inside another function. How do we solve a problem like this? Well, we have the same conditions like before, right? Because if n is equal to 0, then we have to return 0. If n is equal to 1, we have to return 1. This part is totally not needed. We need to think about what should we return here in this place in order to count Fibonacci. Look, when you have Fibonacci of 8, this is really what? The previous number, which is 13, plus the previous number from 13, which is 8. But, well, 13 is really Fibonacci of 7, right? So we could write it like this. And Fibonacci of 6 is really 8, right? So we can write it like this. So Fibonacci of 8 is really the number before it and the number before the 7, right? The result of this function here. And well, if we do something like that, Fibonacci of n is equal really to what? N minus 1, right? Because, well, 8 minus 1 is 7, plus Fibonacci of n minus 2, because 8 minus 2 is 6. So yeah, this thing is like the solution to find any Fibonacci number. So the previous number plus the previous number from this number, right? So we can really just type the same thing here, right? Fibonacci of n minus 1 plus Fibonacci of n minus 2. And to be honest, this is all that we need to do. If we type 8, you'll notice that the result is 21, which is true. And how does it work? Well, we just, as in the recursion, invoke this function and this function to find out what is the result. The problem is that there will be no result until the 1 and 0 is returned, like I showed you in the last lecture, where two lectures before, when we solved the problem of factorial, right? So this is just gonna invoke itself until it gets as a result 1 and 0, which is this and this, right? And then it's gonna just add it up until it gets to the point of Fibonacci of 8. And the solution like this is cool because it looks pretty neat, right? It's well, if you compare to this program, well, this looks pretty complex comparing to this, right? Of course, there you need to understand how recursion works in this situation, so this is a bit complicated, but if you understand it, then this looks pretty neat, right? It's cool. This is hard to look at, right? But what will happen if we type here, for example, 60, and here we type 60? As you can see, we have got instantly result. What will happen here? As you can see, we are waiting for the result, and it's not coming up, even though I have pretty fast computer below me. Okay, if we type here, for example, 40, we'll get the result, but we had to wait a few seconds, right? 45, let's see. As you can see, we are waiting and it's still not here. Yeah, okay, finally we got the result. But as you have noticed, it takes time. So this is pretty not optimal to use for counting things like this. Here you had the result of 60 instantly. Here you had to wait for the 45 number. So if there is counting involved and you need to, go deeply into this invoking function inside another function, then do not use recursion. So why did we use it here? Because to be honest, all the internet, all the programs in new universities use this program as an example. And to be honest, it's pretty cool example to just show how it works, right? But it's not optimal for things like that. So you might be asking yourself, where should I even bother using the recursion if it's so slow? Okay, it's slow. It's slow because you invoke function inside another function, and another function is invoking another function inside another function, and so on, right? That's why it's so slow, right? Because in order to get the result at the start, you need to invoke every function up to the return 1 or 0, right? In this case. So it takes time. But notice that when we are looking at, for example, folders here, right? Folder structure. Notice that we have got here how many levels of that structure. 1, 2, 3, 4. And well, this is fifth. This is not much, right? When we type here 5, we're gonna get the result pretty fast. And this is a great way to use the recursion, because you can use it to search inside folders. You can make a function that will search inside folders, right? And look for items like folders or the files until there is nothing to look for. And you can do it using this neat, this cool, awesome syntax, right? And this is not gonna take longer because there are only five steps, or maybe 9, 10. This is pretty good idea to use searching like this. How would you solve it? Well, you would create a function for searching items, right? So search for file, right? Search for files, and of course this would be called search for files. And here you will need to return something like, for example, nothing, or the item that is found, until everything is found, right? This is of course pretty speeding way of explaining how it works, right? But this is the places where you could use recursion. This place is just to show you how it works, right? Because this solution maybe doesn't look good, it's goggly, but it works faster. And that's how we should create our programs. That's only the lesson. Thank you very much.